Hi, this is Grover with Blue Collar Codes, Quick and Dirty. Episode 24, going to go over stacks and queues. You can find a link to this file if you wish to follow along in the video summary. So we're going to cover, what is a stack and a queue, how to implement them in Python, the kind of unique terms used with them, and then, why use them, and then go into analogies of stacks and queues in real life, so kind of give you a visualization. So what is a stack? One thing I wanted to note is look up or do a Google search of Tower of Hanoi. Just it gives you a kind of a cool visualization as well of how stacks can work together to solve a problem. And a stack is basically a linked list structure or abstraction that is using the last in, first out principle. Meaning things are just stacked. The nodes you're creating are stacked, and then all the references are, trickling down from the top, which is always ends up being the last node that you put in. So here the implementation is you have a top that you're keeping track of, and that's where you're always going to be starting your traversal of any of these elements. Push is what is the term used to add an element to the top of the stack. Pop is the term used to remove the top element from the stack. And then peek is used to simply look at the value of the top element. And so here, when you push, the actual implementation is creating a new node, then it is updating this new node's reference to the next attribute. It's making the existing top, right? And then it's overwriting the reference to the top as the new node. So again, it's creating a new node, updating the reference of next for this new node to the existing top, and then overwriting the top. Pop is doing something similar, except that it's first checking to see if it's empty, because you can't pop an empty list. Then it is making a reference to the top so that you can print the data, because here you're overwriting the top with its next reference, meaning the next node that is being referenced here in the self.top.next now becomes top. So you no longer have access to self.top.data. It becomes what was after it, because essentially here you're not deleting anything strictly, you're just removing the current top from being referenced at all. So after you return this data, now it's going to be garbage collected because there's no references to that prior node. A queue is very similar to the original singly linked list in that it's first in, first out. So you're creating a list, you're keeping track of the front of the list and the rear of the queue, we'll just call it queue, and then the term enqueue, and then dequeue, and then peek remains the same. Enqueue is adding elements, and then dequeue is removing elements. So the unique thing about a queue is you're adding elements to the back, you're removing elements from the front. And so a queue's implementation is simply doing just that. So at enqueue, this is why you're going to maintain a reference to the rear for O1 time complexity of being able to add elements to the end of your queue. And so you create a new node. If it's an empty one, then you're reassigning the front and the back to the same node. If there is already an existent front, then you're going to reassign the last element's next variable, which would be none, right? You're assigning it to the new node, and then now you're re-updating. So essentially, just remember that these are the nodes themselves, right? So you're actually taking the instance of the current rear, you're updating its next attribute, and assigning it to the new node you just created. And now what you're actually doing is overwriting the reference to this existing rear node and making it the new node. So now you just essentially made it reference the rear of it. So you moved the rear pointer, now it's at the new node. Just remember that the element right before this rear element is still pointing to the self.rear, right? So that's why it's going to be maintained in the list. And then dequeue is basically going to remove the first element and then reassign the front, similar to how we did in the stack. And then peek is also self-explanatory. Now, why use a stack or a queue? And it's basically just for different use cases. So a stack is a good way to maintain what has been done, say in a text editor or in a lot of CAM softwares or CAD softwares, say SolidWorks. You know how it has a list or a tree structure of all of the things that you've just done, like I added this line and this point, added this dimension, and how you can undo all of those. That is basically the stack. You're stacking one after the other each operation you perform to add elements to your, say, 3D model, and then you can remove them one by one. And so that's kind of a way that stack can be implemented. You know, here I've listed here, it can be a browser's back button, or it can be a function call stack in programming languages. Now, a queue is similar to just the singly linked list, where, say, when you have something that you need to process sequentially and it has to go in that order, it can't skip around, you don't want the user of the queue abstraction to be able to edit anything other than the last element and process the first element, then you would implement a queue. And this one could be, say, a printer queue or a task scheduler. And then in real life, you know, imagine a stack as being a stack of cards, you know, where you only have access to the top of the stack. You can only add elements to the top and you can only remove elements to the top. And then a queue is just a line of people waiting in line. You know, if you were at the counter, you know, they're not jumping around to all these different people in line. They're going to the person in the front of the line, then the next person, then the next person, and then people are always adding themselves to the back of the line. Now here I've just kind of have a running version to give you kind of a peek at how it works, but it's going to be very self-explanatory when I hit run, in that it's just going to look similar to what you saw in previous episodes. You know, you're adding stuff to this stack, you push these elements in, and now it's going to be printing the stack from the topmost element to the bottom. You're going to pop the 3 in it, so it returned the value 3. You're going to peek at the next value that exists. It removed the 3, so now it peaks and it's at the 2 value. And then, you know, you can pop it again, and now there's only one element left. So the queue, similar here, we're just creating an instance of the queue. We're now adding an element with the data point 1 integer to it. It's creating that node, and then adding 2 more, 1, 2, 3. And then as you can see, it's going to be, it'll print it to show you it's going to print from 1, 2, 3 instead of 3, 2, 1. And then you can dequeue by removing the 1 from it. You can peek at it now and see that it's actually the 2 is the first element now in line, and then so on and so forth. So this was Blue Collar Codes Quick and Dirty, going over queue and stack implementations. Thanks for joining.